Hello everyone, welcome back to our channel. So in this video we came with another question, and this question is also associated with the method of separation of variables, and here also we are going to reduce the given partial differential equation into ODEs. So if you look into the question comprises a function f, which is a function of three variables, that is x, y and z. Okay, that means that because the function is associated with the three variables, we can reduce the given equation into three ordinary differential equations. So let us start. First we will start with the equation, given equation. So the given equation is the Helmholtz equation. Okay, and it is written in Cartesian coordinates. So let us write as it is: del square by del x square plus del square by del y square plus del square by del z square f of x, y, z plus k square f of x, y, z equal to 0. So if you look into the equation has two terms, one term with a second order partial differential equation, and the second term contains a constant k square. Okay, so what we have to do, first of all, we simplify this equation. We will write the equation in simplest form. Let us take this equation as equation, no, don't take, okay. First we will write it in the simplest form and take that as equation number 1. Okay, so let us write it in simplest form. Let us write f x y z is f only. Okay, so the equation can be reduced to del square f by del x square plus del square f by del y square plus del square f by del z square plus k square f is equal to 0. Okay, this should be taken as equation number 1. Now this is our equation, given equation. The second step what we have to do is, we have already noticed that f is a function of x, y and z. Now we have to represent the function f as a product of three functions x, y and z, where x is a function of x, y is a function of y and z is a function of z. Okay, and let us use the separation of a variable method. Okay, so use the method of separation of variables okay, to express the given function f as a product of three functions x, y and z. Okay, so because f is a function of x, y and z, so we can write, okay, f as a product of x, y and z. Okay, where x is a function of x, y is a function of y and z is a function of z. Okay, so let us write f x, y, z is equal to x, y, z, z. Now differentiate f with respect to x, y and z partially twice. Okay, now differentiating the function f, okay, partially with respect to x, y and z twice, we get, what we will get? What we will get here if I differentiate it into twice? Okay, So first del f by del x. So as I already told you, at the time of differentiating any function partially with respect to one variable, the functions of other variables will be taken as constants. So del f by del x will be x dash, means dx by dx y and z. Okay, or del square f by del x square is equal to d square x by dx square y z. Similarly, del f by del y is equal to dy by dy into xz, and here d del square f by del y square is equal to what we will get, d2y by dy square xz. Now del f by del z, what we will get here, that is equal to dz by dz into xy. Now del square f by del z square is equal to what we will get, d square z by dz square xy. Okay, let us take this as equation number 2. Now substitute the values of the values that we have obtained in equation number 2 into equation number 1. Okay, now substituting the values obtained in equation number 2 into equation number 1 to get what we will get. So all the double derivative values are there here, we have to write here, and the rest k square, at k square f we have to keep as it is. Okay, so write it. What do you have to write? That is equal to d square x by dx square yz plus d square y by dy square xz plus d square z by dz square xy plus k square x y z is equal to 0, where f was represented as a product of x, y and z already in equation number, and that means already here we have represented this one, f x y z is equal to x x y y z z. So finally we got this one. Okay, now we have to eliminate this y z, x z, x y and x y z from these terms. In order to do that, let us divide the whole equation by x y z. Okay, so divide the equation by x y z to get what we will get, y and z, y z will be cancelled, we will get 1 by x d square x by dx square, then this one 1 by y d square y by dy square plus 1 by z d square z by dz square plus k square, because xyz and xyz will cancel each other, will give us 0. Now what we have to do, we have to keep this one on the left side and these two we have to move to the right along with this. What we will get, 1 by x d2x by dx square is equal to minus k square minus 1 by y d square y by dy square minus 1 by z d square z by dz square. We got this one. Now look at this equation. On the left side it is okay, on the right side it is not okay. Okay, already we have minus k square and here we have minus 1 by y this much and minus 1 by z this much. So let us take this and this, okay, equate this and this into two separation constants. Okay, so in that way what will happen, we will get two constants here, and again we will take together with k square as a single constant. Okay, clear about that? So let us do that. So how can we do that? Let us take 1 by z. This is equation number 4. Now take, let us take 1 by z d square z by dz square is equal to say minus we can say lambda square, okay, or here k is there, lm, let us take l square, okay, this is equal to l square, clear? L square, that implies what we will get? We will get d square z by dz square minus L square z. This z when will come to right side will be multiplied, and when L square and z will be moved to left side, it will become minus L square z equal to 0. This is our first ODE, ordinary differential equation, equation number 5. The next, second one, 1 by y, this much, let us take this one as m square, 1 by y d square y by dy square is equal to m square. This will give us this square y by dy square. Now this y when will come here, it will be multiplied by m square. When it will be moved to left side, then what will happen? A negative sign will come, m square y equal to 0. This is our second ordinary differential equation, equation number 6. Now substitute the values of L square and m square into equation number 4. Okay, now substitute the values of 1 by y d square y by dy square and 1 by z d square z by dz square into equation number 4 to get what we will get here. Okay, what we will get here, if we will substitute this there, then we will get 1 by x d square x by dx square is equal to minus k square minus m square minus l square, or we can write as minus L square plus k square plus L square plus m square. Okay, k square plus L square plus m square, or we can write 1 by x d square x by dx square is equal to minus of n square, where n square is equal to k square plus L square plus n square. Okay, now what you have to do? You have to bring this x to the right side, and together we bring n square x to the left side. Okay, so what we will get here? D square x by dx square plus n square x equal to 0. This is our third ordinary differential equation. So the three required ODEs are what they are? One is, see here, d square z by dz square minus L square z, d square y by dy square minus m square y equal to 0, and d square x by dx square plus n square x is equal to 0. So let us write d square x by dx square plus n square x equal to 0. Okay, this is one. Okay, d square y by dy square minus m square y equal to 0. This is another. and the last one, and d square z by dz square minus L square z equal to 0. These are the three required ODEs. Okay, I hope you understood the concept, okay, and how to reduce the given partial differential equations into ODEs, okay. So to get more such lecture videos, like, share and subscribe to our channel, and keep the notification icon on so that whenever the new videos will be published, you will get the notification. Thank you.